All right, so now we're going to talk about number 2. And it says here, a toy car moves at a speed of 2 meters per second. So remember, speed is our velocity, but we don't know which direction. How far will it travel in 6 seconds? If it doesn't specify which direction, we're going to assume that it's positive. And if it doesn't specify where it starts, we're going to do the same thing that we did in the other problem, which is we're going to just assume that, we're going to assume that it starts at 0, 0. So here we go. So seconds, meters, and it starts at 0, 0. And so the problem says that it moves at a speed of 2 meters per second. How far will it travel in 6 seconds? So we're going to go ahead and figure that out. So it moves for 6 seconds. And it moves at 2 meters. So for every second, it moves 2 meters. Every second, it moves another 2. So we're going to add 2 meters. So that's actually 4, not 2. Sorry, excuse me. So 4. And then we're going to add 2 to 4. So that's 6. Add another 2 is 8, 10, and 12. So that's what our position timetable looks like. And let's go ahead and make our graph. So we're going to just go by ones here because we went by ones for the time. And for the position, let's go by twos. Whoops. All right, and it says that we started at 0, 0. At 1 second was located at 2, 2 was at 4, 3 was at 6, 4 was at 8, 5 is at 10, 6 is at 12, and it makes this nice straight line. When it's a straight, it's a linear relationship, so that means it's constant velocity. And then we're going to make our motion map. Okay. So let's go ahead and mark our position line. Same way that we did the y-axis. So now the y-axis just kind of tipped over. Now we're just looking at it from side to side. So 10 meters, and then we'll just add this line right here is our 12. Okay, started at 0. And it moved and it landed at 2 after 1 second. After another second, went to 2, 4, another second, moved 2 meters, so now it's at 6. Another 2 seconds, went to 8 meters, so now that's 4 seconds. So now another second went to 2 meters. And it moved for 6, and so this is where it's located after moving for 6 seconds. So the velocity time graph would look like, so 0, 1, 2, 3, 4, 5, and 6 was at a velocity of 2 meters per second. So this was at seconds, this is meters per second. So we have 2 all the way down. Now remember to look at what kind of table or graph it is. This is a position time graph. So position time, this is velocity time. They're different, so make sure that you're paying attention to what table or graph you're looking at. All right, so now we're going to write this part down. I'm just going to go by twos here. 2, 2, 4, 6, -2, -4, -6, 0. And according to this, for 6 seconds, the object was traveling at 2 meters per second. Now remember that we can calculate what the displacement is based on the area underneath this flat slope here. Right, so the displacement is the velocity, which is 2. So 2 meters per second times how much time, which is 6 seconds. So our displacement, this cancels out, and so our displacement is 12 meters. And if we started at 0, we can see that the displacement is 12 meters. Okay. So now let's go ahead and do B. So B is how far will the same car travel in 2 seconds? So we have 0. I don't know why that cursor is there. We'll just deal with it. So 1 and 2. And the position was, it started at 0. It moved 2 meters per second. So it went to 2, moved another 2 seconds. Or sorry, it moved another 2 meters in that 1 second. So it went to 4. So on our graph, it would look like, here's where it is, here's where it is, and here's where it was at 2. So we'll just draw this line next to it. So we should see a blue line and a green line next to each other. Okay. So in our motion map, it should look like we're going to use the same scaling from A so that we can clearly see the comparison. All right, and so at 0, at time 0, at where it started, it was at 0, and it moved 2 meters in that 1 second, and it moved another 2 meters, and this is where it landed at time 2. And the same thing, it moved for 2 seconds, and it was at 2 meters per second all the way. Okay, and its displacement, we can see that 0, so 2, 2, and 2. Now this line means the B movement, and we can still calculate the displacement. So delta x, which is displacement, is equal to Vt. The velocity is 2 meters per second times time, which is 1 and 2 seconds. These units cancel out, and that it is 4 meters, the displacement. We can double check our answer. The displacement from here to here, 4 minus 0, so that's your final position minus your initial position, will give us our delta x, which is 4, which is the same thing here. So we did that right. And so again, I will be showing proportional reasoning later.